Okay, so far we've been discussing the rejection region or the critical value approach. We can call it either one. I'm referring to the same thing. So here we're going to discuss an alternative to that, which is what we're going to call the p-value approach. So let's define this. So let's define what a p-value is. So we can call it a number of things. We can call it the probability of obtaining a test statistic more extreme than the one calculated in step 2. So recall, step 2 is where we calculated our test statistic t-stat. And by more extreme, I mean far from 0. Far from 0. We can also call it the observed level of significance. The observed level of significance. What do I mean by that? It is the lowest level of alpha such that we reject the null hypothesis and accept the alternative. So we need to create a rule around this. So we're going to say we will reject the null hypothesis if the p-value is less than or equal to alpha. And we will fail to reject the null hypothesis if the p-value is greater than alpha. So we'll need to calculate the p-value and compare it to alpha. And alpha is established before we even start a problem. And this is going to be our rule. Okay, so how do we calculate the p-value? Well, recall what we said up here. More extreme. What do I mean by extreme? Far from 0. Okay, so for a one-sided test, so let's focus our attention over here. So the p-value is the probability of obtaining a test statistic more extreme, so a test statistic more extreme than the one obtained, so t-stat. So it's the probability that Tn minus 1 is bigger than our test statistic t-stat. So if we were to plot this, so if our t-stat is over here, our p-value is just represented by this green area. And notice I'm using absolute value signs here, and that's just so we're always operating in the positive or right-hand side of this plot. Okay, now let's talk about two-sided tests. It's the same, very similar formula. The only difference is that we're now multiplying by 2. So the p-value is now 2 times probability Tn minus 1 bigger than t-stat. So it's the probability of obtaining a test statistic more extreme than the one we obtained. So in a two-sided test, we're interested in both positive and negative values, which is why we're multiplying by 2, because the green area, there's now 2 areas. We could have a p-value over here, or we could have a p-value over here. And so we're just going to add those two together for the two-sided test. So this is an alternative to the critical value approach. So let's just summarize this. Let's do a summary of the p-value approach to hypothesis testing. Okay, step 1, it is exactly the same. We're just going to establish our hypotheses as we did before. Step 2, exactly the same. We're going to calculate our test statistic. Step 3, so now instead of creating a rejection region, we're now going to calculate our p-value using the formula we just discussed. So it's either this for one-sided test or it's this for two-sided test. Step 4, make a conclusion. Okay, well, our rule was that if p-value is less than or equal to alpha, we reject H naught, but if p-value is bigger than alpha, then we fail to reject H naught. And then 5 is unchanged. It is our interpretation. Okay, so these are our two approaches. I know we've covered a lot of material, and it probably seems really weird and confusing at this point. But what I recommend is probably keeping 2 pages handy. I would recommend keeping this page. So, here, let me go up. So we had 2 summary pages. This one, let me put a 1 here. So the summary of the critical value approach. I think this page will be helpful for keeping us organized as we work through problems. And then also our p-value page right here, or this page. That way, if these 2 pages of notes are handy, This will help keep us organized and so we can work through problems step by step according to this 5-step process, whether we choose to do the critical value approach or the p-value approach. Okay, so that's all the material. So now we actually want to do some practice, which is what we're going to do in the next video.